For decades, interacting with a computer meant speaking a machine's language. We stood in front of rigid, room-sized mainframes and fed them instructions, punched hole by punched hole. Humans had to adapt their behavior to accommodate the hardware. Eventually, that hardware shrank to fit on our desks, but the underlying mechanics stayed the same. To write an essay or build a spreadsheet, you still have to mentally translate your intentions into a series of physical keystrokes and mouse clicks. In the field of human-computer interaction, or HCI, this barrier is called friction. It is the cognitive load and the physical delay that sits between what you want to achieve and the mechanical steps required to make the machine actually do it. But the era of mechanical translation is coming to a close. We are crossing a threshold where technology is finally being engineered to adapt to us, rather than the other way around. The physical computer, acting as a barrier standing between human intent and digital execution, is being systematically dismantled. Replacing it are three distinct pillars of modern human-computer interaction. The first pillar is hardware, specifically the shift from 2D screens to 3D spatial computing. Instead of staring into a flat rectangle, the digital interface expands outward, turning your entire physical environment into an active workspace. Early attempts at spatial hardware required strapping massive, cumbersome rigs to your face. For this concept to actually work in daily life, the hardware had to evolve into something lightweight and unobtrusive. Today's extended reality, or XR headsets, achieve exactly that. By blending the physical world with digital overlays, they remove the glass barrier of the monitor entirely, allowing digital objects to exist right in front of you. Wearable micro-hardware, like smart rings and tactile sensors, handles the more subtle nuances of movement. These devices capture finger-level gestures, removing the need for bulky handheld controllers. Moving into an open 3D space reconfigures the physical relationship between user and data. This shift creates a more natural field of view, but it also demands a new logic to manage and control that digital depth. This diagram outlines the transition from unimodal to multimodal interaction. It maps out the second pillar of modern HCI, where artificial intelligence and computer vision process multiple streams of human behavior at the exact same time. Instead of tracking a mouse, computer vision tracks the natural movements you already make. It watches your gaze to select an object across the room and reads your hand gestures to manipulate it. Large language models provide the connective logic for these inputs. They parse natural speech and spatial context to translate vague human requests into precise digital commands. In practice, this blend of technologies looks like a user staring at a virtual object, pinching their fingers together to grab it, and simply telling the system to move that over there. Blending these behaviors allows the system to parse human intent directly. You no longer have to learn a machine's syntax. Instead, the machine begins to interpret yours. The third pillar brings this all together at the application layer. This is where spatial hardware and natural interaction combine to eliminate the daily friction of professional workflows. Consider the digital design space. AI-integrated platforms like Figma AI and Usered AI instantly generate complex prototypes and wireframes based entirely on a simple text prompt. By stripping away the mechanical friction of manually drawing every line and placing every button, these applications allow designers to dedicate their time to high-level creative strategy and problem-solving. Beyond design, frictionless AR and VR applications are deploying rapidly across enterprise and healthcare sectors. They enable highly precise remote collaboration and allow surgeons to run complex, interactive training simulations without ever touching a screen. This application layer is where modern HCI delivers its real-world value. It solves complex, domain-specific problems without requiring the user to think or behave like a computer programmer. As these three pillars mature, the computer stops being a destination you visit and becomes an ambient layer of your environment. Interaction evolves from a mechanical task into a continuous, responsive system. This text highlights the critical role of human-centered design in spatial computing. It warns that neglecting HCI principles in these highly immersive environments leads straight to cognitive overload, extreme user frustration, and motion sickness. If we want these tools to feel natural, developers must rigorously adhere to principles of spatial awareness and visual hierarchy. Otherwise, the interface becomes overwhelming rather than helpful. The result of these 3 pillars is a shift toward invisibility. When the mechanics of the interface no longer require conscious thought, the hardware effectively recedes, leaving only your intent.